Okay, that we do. Finally, Faraday's second law of electrolysis. Faraday's second law of electrolysis. This particular law has to do with solutions, two or more solutions. Okay, two or more electrolytes that are connected in series. Faraday's first law has to do with one particular electrolyte, not two, not more. Okay, that is the essence of first and second law. Second law widely deals with electrolytes that are different, but they are connected in series. Let's say we have two electrolytes. One is copper salt, the other one is silver salt, and they are connected in series like this. This is serial connection. They are connected in series. This is where you are likely to employ second law. In fact, solving problem with first law, problem like this with first law cannot work, because you're going to be taking into consideration mass of two elements at the same time. I will mean now. So that's one thing about this. So this is where you're going to apply second law. Okay, the law is simple. The second law is very simple. I just state it's very simple like this, that when, okay, state that when the same quantity that derive the mass of this or this, okay, is passed through different electrolytes, but they are connected in series. Are there? The mass of the elements discharged is directly proportional to the chemical equivalent. Okay, and let me see how it goes there. State when the same quantity of energy is passed through different electrolytes, that's correct. The amount of different substance good produced at the electrode are directly proportional to their chemical equivalent mass. That is second Faraday's law, and it's quite different from this. Okay, looking at it mathematically, very simple there. Okay, just like it states there, mass M is what? Directly proportional to what? To E. This E is what? Equivalent. Call it chemical, not electrochemical, just chemical what? Equivalent. Chemical equivalent. Since there are two masses of substance, because this is going to be two electrolytes. So this can be M1 what? E1. Are there? When you take off this, you're going to have M1 over what? E1 equals to what? What's this? A constant. So this one is for maybe mass of what we call mass of the initial element, the two elements. I suppose you have just like copper connected with silver. Okay, then mass of copper and its equivalent. This one is going to be another mass. You now use M2 against its equivalent. Are you with me? Now, what is this E? E is just relative atomic mass divided by 96,500. That's all. That's all. Or E is what? Relative atomic mass divided by, what's this? Charge or valency. Charge. Or what? Valency. It does appear look like it's continuation of first law. So finally, you can say therefore, complete second law is therefore M1 over what? E1 for one metal is equal to what? M2 over what? E2 for the other metal. Okay, you can call this what? Complete Faraday's second law equation. Okay, please take it out hurriedly. That's Z1 over Z2. That Z is not electrochemical equivalent, but what do I call it? Charge. You know, it should be small z, not the big one. The big one is the electrochemical equivalent, but here we're not making use of big Z. Same. That's why I prefer to use C, charge, so it doesn't look like electrochemical equivalent mass. Okay. I can either solve problems using M1 over M2 equals to E1 over E2 equals to Z1 over Z2 if I choose to. If this one will be complex, I can use this. But I will always know that if I want to know my chemical equivalent for any metal, I will know the atomic mass of the metal, divide by what? This. Or if I don't want to divide by this, I can divide by the what? Valence or charge on the metal.